All right, everyone, board exams are right around the corner, so we are going to do a super fast, rapid-fire revision of mensuration. In just the next few minutes, we're going to nail down all the key formulas and the problem-solving tricks for surface areas and volumes. Let's dive right in. Have you ever actually thought about that? I mean, so much of the world around us is just simple shapes combined together. This chapter is all about giving you the superpower to look at complex stuff and break it down into easy, solvable pieces. And that's exactly what we're going to do today. Okay, first things first. You can't solve any mensuration problem without knowing your building blocks. These formulas, they're your absolute best friends. Seriously, master them, and you're already halfway to the finish line. First up, the good old cylinder. Now for all of these, R is our radius and H is the height. The curved surface area, or CSA, is 2 pi RH. Just, think of it like the paper label wrapped around a can of soup. The total surface area, or TSA, just adds the circular lid on the top and the bottom, which gives us 2 pi r times r plus h. And the volume? Well, that's just the space inside, the area of the base, pi r squared, times the height, h. Next, we've got the cone. It's kind of like the cylinder, but it brings in a new player, L, the slant height. That's the diagonal distance from the pointy tip all the way down to the edge. See how R, H, and L make a perfect right-angled triangle? Yeah, you're going to be using Pythagoras' theorem a lot to find L. The cone's CSA is pi RL. The TSA adds that circular bottom for pi RR plus L, and its volume is 1/3 pi r squared h. And finally, the sphere and its other half, the hemisphere. The logic here is actually super simple and elegant. A sphere's surface area is 4 pi r squared, so it just makes sense that the curved surface of a hemisphere is exactly half of that. 2 pi r squared. Same exact logic for volume. The sphere is 4/3 pi r cubed, and the hemisphere is just half of that, 2/3 pi r cubed. It's a really easy relationship to remember. And hey, here's a fantastic memory trick for you. Picture a cylinder and a cone with the exact same base and height. You'd need to fill that cone with water 3 times to completely fill up the cylinder. So the cone's volume is just 1/3 of the cylinder's. A simple little trick that's going to save you precious time in the exam. All right, with our formulas locked in, let's tackle the first big type of exam question, finding the surface area of combined shapes. This is where we start putting our Lego blocks together. Here we go, a classic board exam problem. We've got a toy, right? It's a cone sitting right on top of a hemisphere, kind of like an ice cream cone. They share the same radius. Our mission, should we choose to accept it, is to find the total area we could paint. So the strategy is absolutely crucial here. We only need the area of the parts we can actually see and touch. That means the curved part of the cone and the curved part of the hemisphere. We completely ignore the flat circle base of the cone and the flat circle top of the hemisphere. Why? Because they're glued together. They're hidden inside the toy. So it's just CSA plus CSA. Easy. Okay, to get the cone's curved area, we first need that slant height, L. Time for our old friend Pythagoras' theorem. The problem gives us a radius of 7 and a height of 24. So L is the square root of 7 squared plus 24 squared. That's the square root of 49 plus 576, which is the square root of 625, and that gives us a nice clean slant height of 25 centimeters. Now we just plug our numbers into the formulas we already know. The cone's CSA is pi RL, which works out to 550 square centimeters. The hemisphere's CSA is 2 pi r squared, which calculates out to 308 square centimeters. Almost there, just one more step. And for the final move, we just add them up. 550 plus 308 gives us our total surface area of 858 square centimeters. And boom, done. See? It's all about breaking it down into small, simple steps. Fantastic job. Now, for the second major type of problem you're going to see, this is where we melt one shape down and remake it into another. And these questions are all about one single powerful idea. Okay, so here's the scene. We take a solid metal ball, we melt it all down into a puddle of liquid metal, and we pour every last drop into a new mold that's shaped like a cylinder. This new cylinder has a different radius, and our job is to figure out how tall it's going to be. And this is it. This is the one single rule you have to remember for these problems. The shape changes, sure. The surface area changes, the dimensions change, but the amount of stuff, the volume, that stays exactly, perfectly the same. This is the whole key. So, to solve this, all we have to do is set the volume of the original shape equal to the volume of the new one. The volume of our sphere has to equal the volume of our new cylinder. We just write down the formulas and plug in all the numbers that we know. Now it's just algebra. And hey, here's a pro tip for you. Don't waste time calculating pi. See how it's on both sides of the equation? We can just cancel it right out. That makes our calculation way, way simpler. After we simplify, we get 288 equals 9 times h. Divide 288 by 9, and we get our answer. The height of the new cylinder is 32 centimeters. That's it. Pretty simple once you know that core idea of volume staying the same. Wow, we have covered a ton of ground in a very short time. So let's bring it all together with a quick summary that you can use for your final last-minute revision. This slide right here, this is your ultimate formula cheat sheet for mensuration. Seriously, go ahead and pause here, take a screenshot, save it to your phone. This is everything you need all in one spot. Glance over it right before you walk into that exam hall. Feeling good? Feeling confident? Excellent. Now it's time to put that confidence to the test. Here are some classic board exam questions. Try solving these yourself to really make sure you've mastered what we've covered. Remember, practice is what turns good into great. And to leave you with a final thought, this math isn't just stuck in your textbook. Look around you right now. Look at a pen, a water bottle, a light bulb. They're all just combinations of cylinders, spheres, and cones. Start seeing the geometry in your everyday world. It's truly the best way to make these lessons stick. Good luck on your exams. You've got this.